Yeah, good afternoon. So the first demo session we have. So morning we discussed about Schlieren, right? So like where so we can capture the any density gradients in the medium. So again, to explain you, we have white paper. So we have a small light source. So this is a Z type Schlieren setup. So we have Z type. So if you see, so there is a small light source, and if you look at that, there is a pinhole because you need to the light has to come through pinhole and then diverge. I'm not sure if like it's a light. So this will come and fall onto. I think camera you're blocking. Yeah. So from the pinhole, light will come. Wait, is blocked. Yeah. So this is coming and falling onto this mirror. So right. So these are like again, depending on the area you want to see, diameter of the mirror. So right now we have 200 diameter. So if you want to see a big area like entire human body or big object, then you need to have such a big mirror. So that means we can have a test section maximum of 20 centimeters because that will form a parallel beam and it will come here, right? And when you remember when the beam is parallel, then you need to put a test section. We have a test section here. At the moment, we have a small heater. So set up here. So this will come again. This mirror will focus back. So when we focus, then we have if you come this side, so we have a small knife edge here, and you can see the light falling on that. So there's a horizontal knife edge, or yeah, this side, I think if you can see, maybe once we start doing experiments, then you can come. So there's a knife edge, and if you see this thing is falling. Like if you see that, right? So that side there was only light. Now you can see that it is forming this image and getting focused here, right? So and then half of it, you can see that it is blocked. So just like whatever the deviated section, so this will be blocked here. So already you can see that this heater setup is there. It is hot. Okay. Taking little time. Like once in a while it gets stuck. So even if you put your hand also, okay, now that convections are there. You can't see. Otherwise, if you put your hand, you can see the like convection from your surface. So this is the setup, and then again, once you block the knife edge, you need a camera lens, and depending on the field of view you want, you can choose the lens. If you want a small field of view, so you use like telescopic kind of a lens, or if you want to have a large field of view, you can have a short focal length. They're just like thinking, how many of you use cameras or photography books, right? If you want to take a big, like big, in a lot of people around, use short focal length lens, right? 18 mm 55. So you get like a wide angle, or wide angle, you call it as wide angle lens. Otherwise, you have like telescopic lenses where you zoom in and take in a small area. So then this is the camera. So this is a high speed camera we have. So any fast phenomena you can capture. So you need not have if something is slow moving thing, you need not use this is overkill. So you can use a normal SLR with the same setups. You can use even normal SLR cameras. You should be able to get quite a good images. So right. So now we'll demonstrate couple of things. Right. First thing is this from the heater, like how this currents once we heat up, how things goes on when we put a small drop on that. So right, if you put a small drop, what happens if you have a hot surface and put a water drop? Yeah, evaporation, only evaporation, or do you see you have a Leidenfrost effect, like so then like you can see that drop bouncing, and same time there will be a steam going up. So that we will demonstrate, and after that morning we discussed like what is the importance of putting a knife edge right? You put a horizontal, how this changes. If you put a, maybe we can put a candle that time and then show. Yeah. So we'll put a candle and show that, like, if it is a vertical, you see that half black, half, and then if you don't position properly, then you will have a problem, like how it changes, or you keep moving horizontally, like you keep blocking more and more, how the contrast changes, all that. And after that, what we do is we change the lens, get large field of view, and look at the shock, there's mark cones, right? And how this mark, morning is, we also saw that, right? How over the, yeah, over the couple of classes, we saw like how this shock wave interacts with the surface. Then you can see the shock moving. We're not able to create entire just like your projectile shocks, but with mark cone, we could still see that. Right? So on, you started the heater, right? You can switch to the, okay. Yeah, here we can see that this is the heater surface, right? We have a heater surface here. I can't put the finger there, like it is. So 127 degrees, you can see that. So there is a lot of convection going on, right? Like here, you can see that the hot air gets heated up and then that creates a density gradient. But with naked eye, you will not be able, you're not able to see anything, right? So now we want to have we put
what plane will it capture?
So usually it is a line of sight. So in this plane, it will be capturing. It will not. It is almost like line of sight measurements. Wherever you put this in the so this collimated length, so it will be, it will get focused. So again, it is not like exactly can't keep in one focal point. So wherever you put, so even if you put something hot here, so that also will come. Yeah.
Stop recording. Video.
Do we need to record or just finish? Okay, later play it. Yeah. It is ready, right?
Ready also.
So we have putting a small drop.
It's still off and we can show.
Yeah, you can. So here, these images we are capturing at 1000 frames per second. So that later we can see in slow motion. Yeah, that was continuously recording. Now you can see that everything going. Okay, so sometimes it just pauses a bit. Just bear with that. Then you can see that drops bouncing. So you can even go to higher temperature. Yeah. If you go to higher temperature, I think you can see it. Okay. So then you can ask, like, what is it just for fun, right? You can get the size of the drops. Let's say something is happening faster, especially like drop impact on a surface, hot surface or a cool surface, like aircraft wings, all that. If the drop impacts on the surface, then you can see that first how it is spreading, or is it bouncing, or in case if it hits and splash into multiple drops, what could be the size of the drop? or if there is a film formation, or what is the velocity at which something is hitting, all that we can get using this. So because so you can calibrate this at the moment. Size is just like we don't know, it is in the pixels, right? So this image sensor will have a standard size, right? Some pixels by, so this is like 1,000 pixels. Let's say it is 1,000 pixels by 1,000 pixels. Yeah, become good. So it is the pixel, some pixels. Now we can do little calibration. So right, I put a scale, then you know the length, and this many, let's say we are capturing 10 centimeters, right? So 100 millimeters is captured in 1,000 pixels. Then the calibration will be like 0.1 millimeter per pixel. Now we can do like how much means if there is a drop, we can measure what is the diameter in pixel and calibrate and get that. And now we have multiple frames. Then in the frame one time, we know like it is we are capturing it, let's say 1,000 frames per second. So that means time gap between two frames will be 1 millisecond. So in 1 millisecond, if something moved this many distance, then we can get like what is the velocity also. So using that, so we can get the velocities and sizes, all right. And using a Schlieren, again, anyway, you can see that like where the density gradients all are there, right? Uh, so you want to put once again the little harder surface. Will we just try? Okay, wait, got stuck. Yeah, now the temperature is higher. You can see bit stronger currents also. So this, you can say in coalescence all that. So now let's look at what we can do. So shall we do on that, or you want to capture the large? Same, sir. Okay, same. Okay, let's. So now we look at like just carefully eating. focus.
I think that's
Okay. So now we look at like we have a small compressor here. Fullness. Okay. We have a small compressor from which you want to record. So like we are taking 7 bar, 8 bar pressure we are putting it. So then this is coming through a small nozzle. So it will be like under expanded, like morning we were discussing, right? Over expanded or under expanded, right? So let's look at the flow through that. So like, you know,
sure. Yeah, right. Ready. Ready, sir.
okay. Can we fix that also? We can't fix. Okay. Wait, wait, wait. It's not recording. It got hang. Yeah. Now
Okay, again.
keep getting. Yeah. We can zoom in a bit. So there you can see. Yeah, there you can see this mark, diamonds mark appearing. And then you can even see like how they interact with the surface, right? No, just without that, without that interaction, can we just shoot? It just keeps hanging.
కాలేదు అదే ఇచ్చేవచ్చు ఇచ్చి వచ్చేస్తుంది
Marfil. Pressure is not sufficient. How much will be?
4 will go up to 8
Ah, okay. Earlier it was when we started. Okay. Yeah, we'll just maybe pause for some time. Ah, okay, okay. Oh, yeah.
that we can see 8 bar to 4 bar.
No, he says that once we start, right? Say 8 bar to 4 bar, we can continuously show so that I think that also we can just hold for long. Can we fix this on something? And then other one, yeah, in between. That's what without first to show that and then play with that, removing the knife edge and moving around up and down like how the contrast. So put a candle, I think that will be easy, like candle flame, and then if we move this knife edge, then we'll see the effect. But this just holding it stable will be recoil. Yeah, that is also problem, like recoiling. Maybe when continuously see. Now, yeah, now we can see that what you said, like pressure. Yeah, yeah. So at the start, right, you have like a quite a strong, and then yeah, yeah. At the moment, we are playing at 60 frames per second. This was recorded at 1,000 frames per second, so like almost 15 times slower than. Okay, this got hang over there. Mm-hmm. Okay, as we started, the pressure kept on falling, right? Is it too slow? We can just increase the frame. Between it just hangs up. I think the data transfer.
This all.
Yeah, given the length also it shortened. A number of diamonds formed. It kept on reducing. Width also reduced. 13 to 1,000 frame rate recorded, 120 FPS. We're skipping 4. So 120 FPS we are running. We're now almost like slowly. And if we have a convergent divergent, we can make it even stronger. Like this is just like a simple pipe. We are now gone. And after some time, you see only that jet coming out. I think yeah, now you can only see that jet coming out here. Yeah, it is just like tiny jet coming out. Okay.
You recorded and you, when did you record? You, after you started, you recorded?
Yes, yes, yeah. Well,
Once it's figured, then you still release information how.
okay, okay, yeah, we can just see that. So start recording. Okay. Yeah, it must be there.
Awesome.
I think that was out of the uh, somewhere here.
Okay, okay.
No, no.
This is meaning of it.
This is where it started. Maybe we can. It's the problem. Suddenly hanging up. So shall I just focus there?
Okay, okay.
Yeah. Somewhere here it starts. Like frame by frame, if we,
Yeah.
it's here it starts. Very slowly. And then it just forms it. So here it is a free stream. So this is like a free stream one. Want to try next?
Change the place.
Okay. This with the candle we can't do it, or we have to change the lamp. Uh-huh. But height, we'll get the.
Yes, sir. Change this zone.
Uh-huh.
I will do.
Okay. So maybe we'll show that it's not.
Okay. So what is the red pixel?
Mhm.
What are the red pixels?
So this is saturation. Saturation of the camera means too much light. The other thing is like couple of things we can. Why it is on the side?
I think we can move it.
Uh-huh.
A little bit more into the range.
Yeah.
Just once you put the flame off, yeah.
Can we put a pulse?
Sure.
Okay, no, then this will. No, we have to reduce the candle. Cut the candle means if we increase the height, then this will go out of this. Arm. We can cut the candle. You have enough? That is. Right. Chin.
కొంచెం adjust చేయాలి. Adjust
Which one? That's not like why you reserved it.
You change the focus. Like
Okay. That will be too small. This is good or even lower will be better. We know the other small candle, what we have. No, that is too. I think it is. What do we have? A smaller post?
Santi's place.
No, smaller post. Because if the candle comes really low, it will be good.
Right.
Flame and then hot air, all that will come. No, it is not coming directly. That high. No, some 4 or 5. We don't. This. Enough. Is this? This is good. Mhm. Okay, just leave it like this. This is good. We'll focus only on. Why is it not coming? No, this image is hanging. It's okay. I think. Ignite. Let's switch off AC. Here. This is this is not. This is yeah, frame rate. I think we need to. Saturating is it? Shall I just reduce the exposure?
Reduce the opportunity.
Yeah. Still, it is.
Increase the speed.
Yeah, yeah. All right, I think I can reduce. It's hanging up a lot. Yeah.
We can set it in 6 months.
Mm-hmm.
We can set it in 6 months.
Okay. Yeah, here you can see the candle flame. This red is this portion, and then hot gases going up.
Which we don't see in our naked eye
Yeah, naked eye we don't see. Slightly
because of the density gradients.
density gradients. Yeah. So we only see the flame, which is here, this red portion, right? So that is a flame visible to us. It is this one is not so high speed, right? So this is not like this is yeah. Switch off, you can get better, is it? Yeah, same thing. Now we can try this thing. Moving the, or we'll set up with a Zeiss lens, is it?
This one's here.
Okay, we'll get a large field of view. If we block that light, we see only the flame. We can just block that only the flame. So if we want a large field of view, let's look at changing the lens. So we can, if we focus, then we will see only the.
It's going away.
Mm-hmm.
Vapors are going away from the this one.
Mm-hmm.
Field of view.
Okay. Yeah, that's okay. It is not straight, it is going away from the field of. So shall we change the lens? Okay. So this is like 70 to 300 mm zoom lens. So we have one 50 mm lens. So where, as I was telling, like if you need large field of view, you work with a short focal length. So we have the short focal length lens, which we can change.
Did you tell them the cost of the camera?
No, sir. But I think this kind of
knife is also, you can show the shadowgraphs that are also here in this.
Shadow graph. Yeah.
That you can do at the last.
Yeah.
Just removing the knife.
Tomorrow, Friday morning,
You have to say-
I'll
That,
just.
that lead you are saying, but shadowgraph you are not saying.
Yeah.
Here, if you remove the knife, is on the
Knife edge, then we need to put
Okay.
this thing.
No, jet setup also. No, knife edge means you are just
Yeah.
really, removing this. Then you are all the parallel like this. You are.
Yeah. Yeah. Yeah, that is also yes. We can remove the knife edge initially.
If you remove the knife edge, yes, sir, then it will become shadowgraph. Shadowgraph. Yes, sir. Yes, sir. That was now the difference in the video. You can see that we are different between the sensitivity. Yes, fine. So,
No, saturating.
so 4 lakh.
Yeah. Just remove. Silicon. Mm-hmm. Increase the shutters. Why that the red thing is coming here? Hmm.
Yeah.
Okay. Yeah, this is the one. Like, okay. If we remove the knife edge completely, and then slowly start putting, I think you can just move completely below.
Yeah.
Right.
Only smaller gradients.
Yeah, only like smaller gradients. You can see that this is a shadow graph, right? So whatever we saw, there is no knife edge. All the light is coming and going there. So now we have like okay, more slowly.
Just
Yeah.
Yeah.
This is hanging up so badly today.
And then you have to shut it down for 5 minutes.
It's not that hot. Not at all hot. It is blocked completely.
Yes.
Yeah. So there's a vertical knife edge.
Vertical knife edge.
And yeah.
We can also put a small hole.
Pinhole.
Pinhole, and then you need to have another circumferential one where you give a face contrast.
Okay.
Graded filter.
That will be much more.
Mm-hmm. This we can just now it's like a shadow graph. Wait.
Looks more like a direct image.
Yeah, this is direct image, right? We don't have.
Yeah, it's a little bit of that.
And now I think it starts falling. You can see that starts falling, right? I can see. Mm-hmm. You want to go on that side.
If it is towards the mirror, it gets blocked from the down.
Yeah.
Open this. Yes.
Yes.
Allen.
Now we can explain. Yeah. Just keep explaining.
Open. Yeah. Terracotta. So you can see it is fully blocked. That is like percentage cutoff, how much it is cut off. And like one point of time, like if you go this way, you can see it is blocking from down. This is towards the mirror. I'm moving down, moving towards the mirror. You can see it is blocking from the down. And if I go other way, so somewhere it will block from the top. You can see it is blocking from the top, is it? Yeah. So we have to keep it exactly somewhere in the middle so that it gets uniformly blocked. So that is where we get this density gradient correct. So if you see now here, it is almost like uniformly blocked, is it? Yeah. Here you can see. So this is percentage cutoff. Okay. Left or right, if you want to see. Yes. From left. So from left. It acts like vertical. I'm keeping it from the side, cutting it off from the side. Somewhere it should go other way. If you see, it is going from the other way. Is it? Previously it was from the left, now it is from the right. So yeah. Now it is like almost cut off from the, it is like vertical knife edge. And you can see one side darker, on the other side it is lighter. So like whatever getting refracted from this side, it is blocked. This side it is becoming sharper, like brighter. So partly it is cut off. It is like partly cut off. What are the refracted rays from that side? It is cut off. This side it is becoming bright. Yeah, no? So I will go back to the same portion. So bottom. Top. Yeah, somewhere in between. అంతే అంతే. సో you can see, or even a little bit if you want to. So more the like sensitivity we saw sir explain, like how much is the obstruction, more the obstruction, more the sensitivity. So if I more,
Here the focal length of mirror we are not going to change. If we become sensitivity is focal length over the obstruction, right? So only thing is we can change the obstruction.
okay, no? So this is done. We will do on this.
I think so. Then we have
Okay.
Options, no?
like we have another like you can take a deodorant this thing flame, then we can look at how the flame spreads. Probably that will. So careful.
So
It will record this thing, right?
yes sir.
I just increase.
Yes.
Okay.
Frame rate increase చేస్తాం కదా.
You can explain.
You want to
Okay.
Initially, just you put the
Deodorant
itself. Wait. Later you can have ignition. No, don't ignite. Shall we have?
Yeah, you can see. So,
Can we have a little brighter?
yes sir, yes sir.
Do we have aperture on this?
Aperture is there sir.
Or is
If
fully
yes sir, it is close sir.
okay?
16 it is there, f16.
Okay.
Actually,
Yeah, this is brighter.
yes sir.
Okay.
So we can see the vapors coming from the deodorant.
Yes, the structure of the spray coming even in the castor and even in the very simple.
Industrial spray we can record at high speed. Yeah, spray. Stop. Yeah. Yeah, you can see that. Again, it is like a mixing. Then it'll evaporate and mix, right? So now we will see like ignite it. It will create a flame, right? So and even initially we can even see that dynamics, like how the ignition occurs, how this flame spread occurs, and then
Kind of frame rate.
frame rate we can go just
Yes.
slightly higher. Would it be too dark?
Just checking.
Unless
చెక్ చేస్తాం కావాలంటే మళ్ళీ చేయొచ్చు. ఎండ్లో పెట్టుకుంటాం, ట్రిగర్ ఎండ్లో పెట్టుకుంటాం.
Okay.
Yes, sir. ఒకసారి చెక్ చేస్తారా? చెక్ చేసుకోండి, చెక్ చేసుకోండి ఒకసారి, తర్వాత రికార్డ్ చేసి ఒకసారి చెక్ చేసుకోండి, తర్వాత మళ్ళీ you can check it once. After that, check the flame once. After that, I will start. After that, second time I will start. Yeah, somewhere you can keep the ఇది దాంట్లో పెట్టుకోండి. Yeah, there, yeah, somewhere
It has to be ignition.
yeah, somewhere there, yes. Yeah. Oh, you can see like vapors already came. So vapors are already there. The spray is already there. Once ignition started,
We can
maybe yeah.
We'll go low frame.
Yes.
Yeah. Then you can see the flickering of ignition.
Yeah, it is going there.
Zoom.
Yeah.
And
So here, slightly we can see the spark is coming. Spark is there here. Now coming back.
playing backwards.
Yes. Yeah, spark is initiated.
Clinton.
Playing back.
Okay.
Now,
I think it took time to ignite. Maybe I think it is not ignited yet. And there the resignation is there. Now it got ignited, right? Now you
Yeah.
can see the spread of the flame. Yes. So now you can see the spread, like how the flame is spreading, right? So this is where you can get like
Yeah.
how fast the flame is spreading.
here we can see.
And the moment you have flame, the density gradients will be like much higher.
So we can see a stronger dense gradient here. Is it like vapor front? So wave, no, like wave front, flame front.
But again, one more flame can be
Yeah,
pressed. In fact, there is a flame. This one is a flame. The flame is there.
One more triangle.
Load.
Actually, without like we started the spray first. Now spray spark first. After that, the spray.
No, we started spark, then spray.
Is it? Actually, I was seeing the spray.
If you go first, then you can see the gradients coming from the
Spray.
Yeah, spray was already there.
No, there was the spark was there.
Okay, spark was there. Okay. Then okay. Maybe it was not ignited. Yeah. Yeah. Maybe it was not ignited. It took time to get.
Okay. It was offset. It was offset.
Manaro, on that day we saw. Is it like sharp?
quantity is more on
Okay.
we have other space. But very precise.
Okay.
4 is very specific.
Okay, got over it.
Okay.
This 4 is very
Okay. Otherwise, we'll try one more time. Yeah. No. కొంచెం ఇటు సైడ్ ఏమో. Yeah. పైనుంచి పెట్టాలి.
No.
Yeah.
I'm not sure. This is this.
the delay in net.
Yeah. No, Yeah. Strong movement as well. Yeah.
Ignition.
You can see strong movement here.
Now, like you can see the flame spread completely, right? So this sort of a complex flame.
We have a recording with that you can
Hmm.
Yeah, you have recorded video. Yeah, you can show that.
Yeah, yeah.
Recorded video. That is also.
Are there any fuels for which the flame front can travel upstream? Like right now, we see that the same is
Like the force, this velocity, right? See, you have a flame here. If you supply flame doesn't know which direction it is traveling. It just if it goes in this direction. So only thing is if you supply continuously, this if the flame velocity, you call it as a flame velocity. If this matches at the incoming velocity, flame will be at one position. If it is more, it will go like this. If it is slow, it will go backward.
The ring is playing with now. What we are capturing is actually the player plus the luminous player. Luminosity is all around this.
The luminosity, this is like luminosity is overlaid on.
ఇంకోటి ఉంది ఏదో ఫస్ట్ ది అనుకుంటా మూడు తీసాం కదా ఫస్ట్
Invisible filter. So that case, Schlieren, if you illuminate with particular wavelength, right, and capture only that wavelength.
ఇంకోటి తెచ్చా
because
Platinum
That won't be. That won't be.
that one we see more white.
But otherwise, also if the illumination, the LED, if it is a particular
అదర్ డియోడ్రెంట్ వేయచ్చు లైక్ స్ట్రాంగ్ అదర్ డియోడ్రెంట్ like strong like you can see
Going very now.
yeah.
Even with this,
Okay.
it was going much faster.
yes maybe content of alcohol is more okay.
There is one here.
We'll try or
Anyways, something is going to. What else we have?
that's it.
We can put that.
That kind of, yeah, that I mean, given the small temperature gradients, also we can capture.
Top map.
Malayalam.
Okay. సో కనిపించలేదు ఎక్కువ తెలియలేదు మేబీ
Looking. Current.
The background,
No background.
this thing is much stronger than
Basic.
blow. Yeah, someone takes. Now the heater we saw that, right? Soldering iron and heater one and same. Then we can see that. Like even hand, I think if we need to be very sensitive.
Yeah.
Yeah,
like-
let's see that. Okay. You rub more.
yeah.
Right.
Yeah.
So how much change in the refractive index? Morning we saw, right? The
Temperature.
temperature, density change, and then if you have even 100 times density change, refractive index change will be only 2%. Now imagine that hardly how much temperature change it will be. So maybe 5 degrees, so 5 to 10 degrees, then corresponding density change will be even smaller, and the refractive index change will be even like 0.001%. Even that one will be able to capture.
Right on that. And it's slowly running. Actually, it's so very different.
If you if there is a water like evaporating, that will show different. Like again, so for the Schlieren tools, it will show up the density gradient. Like a stronger the density, like other time we saw, right? So we had the deodorant. So the density gradient between when there was no flame, it was not much. Then you can see the tiny grade. The moment there is a flame, then you have like a 1 order or 2 order magnitude difference. Then you can clearly see. Yeah, even if you have a sweat, it is evaporating, then it will show. But maybe like you need to increase the sensitivity even higher.